What's he doing in there? We have a right to know.
So the new board consists of, I added a 2.1 millimeter power jack. I basically consolidated everything. The old one obviously had the trinket um, on one board with all of its interconnections, and the relays, two relays on their own board, and then the audio amplifier. This is the new audio amplifier, was a thing into itself, and the power jack was a component into itself. So I incorporated all this into one board because I now only use one relay because I'm using a new amplifier, and this amp is a 5-volt amplifier. The Dayton that I was using is a 12-volt, and so I had to split the voltages and so I had to have two relays to apply 5 volts to the Pi, 12 volts to the Dayton audio amp whenever the green button is pushed. Because I got rid of that amp, I saved a whole lot of space because this thing is tiny, as you can see. It's about the same size as the trinket, and it uses 5 volts also. So down to one relay, I can put it all on one board. And then I put the 2.1 millimeter DC in jack on the same board. So I've got my headers here to connect the button. This goes out to the Pi, power to the Pi. There's a transistor for switching on the relay. Then on the other side here, I have the headers, a single header, for the analog input from GPIO 25 on the Raspberry Pi to tell the trinket when the Pi is booted, so it can then take over the responsibilities of holding the relay energized. So here's a close-up of the amp. If I can get this to focus. There it is. There's the amp. And then there's the ugly backside, in which I put the relay, obviously, and then I put the diode to protect for whenever you de-energize the relay to protect the transistor. I put the diode on the backside. Cleaner, easier. So there's the new board for the Raspberry Pi single station radio. Okay, here we are with the finished Raspberry Pi radio for my mom. As you can see, Raspberry Pi Model B. I think I've got a 4 gig card in there. Had to strip Jesse Light down. Had to actually keep it from expanding the file system. And that may be an 8 gig card. I'm not sure. It probably is an 8. I'm probably lying. Jesse Light on there. MPD and MPC handling the streaming duties. With MPD and MPC, you simply do MPC add and then put the address to the stream. And then once you add that, and I think I add that in ETC RC local, I found that you can then take it out of there because once it's added to MPD, it stays in there. So that's cool. So I have that running at boot up. And so the changes I made are I'll move some things around, cut out some more of this case over here because I plan to use Ethernet at a later date. Right now I'm using Wi-Fi. I plan to use Ethernet at a later date just for better reliability. And so the main changes were I built this new printed circuit board over here. I was able to drop down to one relay instead of two because I ditched the old Dayton 12-volt amplifier in favor of this. This thing cost me $2.50 plus $1.50. No, it cost me $1.50 plus $2.50 shipping on eBay. And I'll put a link up here and show which one this is. I think it's the it's a 3-watt, I believe, 2-channel. Although I'm only using 1-channel amplifier. So I ditched the Dayton 12-volt, and so that allowed me to go to one relay instead of two because I'm only having to switch now 5 volts because this runs off 5 volts, and so the relay switches that. That's the 5 volts going to it there, and then the 5 volts also goes to Let's see, where does it run to 5 volts? That switches 5 volts over here. Over here switches 5 volts that goes over to the Raspberry Pi and powers that up, tells that to boot. And so I was able to put all this on one board with the audio amp and the single relay. And so what happens is the trinket's running all the time, and then it's watching for it's watching for this box for you to hit the green button to turn it on, and that then sends power sends 5 volts out to the amplifier and to the Pi and tells it to boot up. It does a 60-second deal where it sends the signal. It activates the relay for 60 seconds, and then I have one of the pins on the relay on the Pi, I think it's GPIO 25, that I have just set high via Python script, and I have that connected over to the another analog input on the trinket, and so then that takes over. That basically tells the trinket, hey, the Pi is now booted. Whenever the 60 seconds times out from pushing the green button over here, this signal from the Pi takes over and keeps the relay energized. So as long as the Pi is running, the relay is energized, which keeps power going to the Pi, which keeps the Pi running, blah, blah, blah. So then, that's how that all powers up. And so I changed that, new board here, moved some stuff around, and then I had this, I think I had this in the other one, this buck converter. I was going to use a 5 volt DC input, but the ones I had, these wall warts and some of the other unregulated power supplies, the 5 volts isn't that reliable. It's fine for some things, but I wanted a pretty reliable 5 volt source for the Pi. So I decided to keep the buck converter, and then I used an old Sony, it's actually an 8.4 DC 1 amp power supply that I used. It came with an old Sony camcorder from, 15 years ago. But I had it laying around because it put out 8.4 volts at 1 amp. It was fairly useless for most things, but perfect for this. So I have 8.4 volts coming into the buck converter. That bucks it down to, adjusted that to 5.1 volts because of losses here and there with the 5.1. By the time power gets to the circuitry here and over to the Pi, I think it's down to about 5.05. And because of the circuitry in here and the cap filtering and everything, it's a nice, clean, good-looking 5 volts. So I was able to get everything back inside here, and everything looks good. This little amplifier here had a potentiometer on it. There was a power switch and then also a volume control. But I didn't want the volume control on the bass here like it was in the other iteration, because this bass sits down either at the bottom shelf of the nightstand, or it may even sit on the floor of my mom's nightstand. And mostly she leaves the volume at a set volume. But every now and then she wants to turn it up a little bit, if there's a song she really likes or whatever. And so I wanted to put a volume control. I didn't want her to have to reach down there because she wouldn't do it. So I wanted to put a volume control up on the control box. And so I did. And so I just took the potentiometer off of here and then ran cable up. And so I mounted the potentiometer on the control box. It doesn't control whether the amp's on or off because that's hardwired, but it lets her control the volume from the control box. And let's see, what else? I believe that's all there is to see here on the box. Let's see, other than what I added, and I'll show more of this box in a minute, but I added LEDs. Get this down here so it's more like in focus. I added LEDs, and these are simply because Mom's going to be using this, in the dark or in the near dark in her room. Because she turns the radio on when she can't sleep or to help her fall asleep. And so I wanted to add some LEDs just to kind of guide her to the buttons in case she can't see the buttons, or, it's, just a little guide to let her know, yeah, she's in the right vicinity. She actually says she was using it just fine the way it was, but I wanted to add some LEDs to it because what project isn't better with some LEDs, man? So I added a green one that's on. The green is on all the time until you turn everything on, then the green goes off. So basically the LEDs are on to guide her to the buttons, but they're only on when they need to be on, when that button is active, if you want to say. So when we first power it up, the green LED is on because the shutdown and shutdown delay won't work because the thing isn't on. The only one that'll work, that'll do anything, is the green one to turn it on. So that's on. So as soon as you push that, that tells the trinket to energize everything. The Pi starts booting up. But also as soon as you do that, what I have powering the green LED is the other leg of the relay. You know how this is a dual throw relay, single pole dual throw. And so I have 5 volts going to the center contact. And when this is energized, it sends the 5 volts over to the Raspberry Pi and to the audio amp. But in its off position, it sends 5 volts via this header and this 1.1K resistor out to the green LED to guide your hand to the green LED. So as soon as you turn it on, this flips over, turns the green LED off, because now it won't do anything. The green button won't, because you've already turned it on. And so that was a handy little way of being able to switch between, having only the LEDs on that show an active button. Once you turn it on, the green button's no longer active. It won't do anything. So that's that. And then the other 2 buttons I have, obviously, are same as before. The red one sends the console command, shut down TAC H now, which means halt the computer and turn it off now. And the yellow one does the same thing, except it does a delay. It does 1 hour delay, shut down, halt, TAC H. I think I did it 60 minutes to give Mom a sleep timer because she likes to fall asleep to it sometimes. And so for the red and the yellow LEDs, they only become active when the Pi boots up. So I wrote a script, and I'll show you in the video here. I'll pull the script up and show you. But the script then powers up GPIO pins 17 and 27, and I have those connected to drive the yellow LED and the red LED. So once you turn it on, those are now active, meaning those are the only 2 that you can touch and will actually do anything. And so I have it set so that they're both on solid because they're both active. If you hit the red one, that's halt now. Then they both go dark just as soon as the Pi shuts down because it takes power away from the GPIO pins. But I have written in the script that if you choose the delay, I wanted some way so that Mom could look at the delay, because sometimes she's told me that she's kind of forgotten whether she hit the timer or delay or not. So I wanted a visual indicator to let her know whether she'd hit it or not. So I put this in the Python code, so when you hit the yellow button, it starts the yellow button to blinking. So it sends the command via another script to tell the Pi to shut down in an hour, but via the LED blinking script, it tells this to start blinking when you press it. So she can look over there and she sees a blinking yellow LED. She'll know she's hit the timer. It's within the 1 hour of shutdown for the timer. So that's what's going on with that. And now I'm going to, just for the heck of it, I'm going to close this up, because that is very satisfying to be able to close up a project after you're done. There's nothing more satisfying than being able to say, there, done. And I'll probably have this just setting upside down like that. So the Pi and everything's upside down. But then there are the inputs and the outputs. And so, yeah, I'll edit this crap out. So then what we'll do is we'll connect power. And I don't have Wi-Fi out here in the shop, so we'll connect the Ethernet. So we'll apply power. You can see the green LED has lit up very nicely, although it's showing white on here. But that is lit up because that's the only button that is active. When it's off, that means the trinket's on, but the Raspberry Pi has no power applied to it. The audio amp has no power applied to it, so in the dark, as Mom is using this green LED being lit will guide her hand to it. Here's the volume control knob that I told you I put up here. And so then she hits this button and that'll turn it on, and then the green LED will go out immediately, and then after the Pi boots up, the red LED and the yellow LED will light, showing that these two buttons are now active. The halt now and the halt after 1 hour buttons are active now. So, and what will also happen after these LEDs come on is the MPD will be called up by another script, and WSM 650 AM audio stream will immediately start streaming, and we should hear it out of the speaker. You can now see that the red and the yellow LEDs have come on to guide her hand in the night to either the shut down now or shut down within an hour button. And in a second, we should hear the audio. Waiting.
Become someone's breathtaking home. It'll get started Saturday, September 17th at 9 a.m. How do you register? Very simple. Go to the website at honestabe.com or give them a call, toll free at 1-800-3695. An Honest Abe log home, it's what you've always wanted.
Hey there, travelers. You going somewhere? Need a hotel? Then call Hotel Wiz anytime, day or night, for rates too low to publish.
So there's WSM 650 streaming perfectly from my mom. If I hit the red now, it'll just immediately shut down. What I'll do is I'll hit the yellow first, which will send the shutdown in an hour command. And also the yellow LED will start blinking to let her know that the timer's going. Now the yellow LED is blinking, but the red's still lit because she can still shut it down now. So they're both still active, and so it will shut down in an hour, or we can shut down now. And there we go. Audio stream shut down. When the Pi itself shut down, that turned the GPIO pins off that were powering the red and the yellow LEDs. And then it also turned off I think it's GPIO 25 that was holding the relay active via the trinket. And so as soon as that went off, the relay turned off, killing power to the Raspberry Pi and the audio amp. And then also, as soon as that relay switched over to its resting position, that position is what I have powering the green LED. So now the green LED came back on, letting you know that, okay, this is now active again, meaning you can press the green LED button and turn everything back on again. And so that's it. We're finished. We're finished. That was the last part of the puzzle. And hope you got something out of it.